All right, we're going to be on page 47. We're going to do chapter 21 notes today. Your homework will be pages 50 and 51 in your packet. But before we get into this, I kind of want to tie this to stuff that we have recently done and talk about it. So this right here is a picture of the sampling distribution that we made for the proportion of blue M&Ms. Okay. Now, since the M&M company claims that there's 20.7% M&Ms, what would our null hypothesis be? If we were to run a hypothesis test to determine if the M&M's company is correct, what would our null hypothesis be? Okay, so our null hypothesis, our P would be the proportion of blue M&Ms made. And our null hypothesis would be that P is 0.207. Okay, and then we haven't really discussed the alternative. I guess we were trying to see if it's not equal to, okay, 0.207. All right. So, let me go ahead and zoom in here. According to the way hypothesis tests work, let's just kind of pretend like we were doing what we were talking about before. Here is 2 standard deviations out. Okay, and here was the 20.7%. Here was 2 standard deviations out. Okay, so there's our 2 standard deviations out, and here's 1, and here's 1. Okay. So according to this, all of these p-hats that are in the center, all of these ones in the center that are around the null hypothesis are there because of what? Sampling variability. Very good. Now, if this is 2 standard deviations up to 2 standard deviations down, how much data, of course, do we expect to be in that section there? Within 2 standard deviations of the mean. Yes, 95% of all samples of all p-hats of that size will be in there. Good. Then what does that put out here in this tail? This upper tail. Okay, good. So 2.5% of all p-hats are going to be up here. And then likewise down here as well. Okay, if we were to run a hypothesis test with the null hypothesis being 20% and so on and so forth, and I got this sample right here. I did 50 M&Ms and the proportion of blue M&Ms that I got was this one right here. What would my conclusion be in my test? Good. I would end up rejecting the null because these samples over here are in the rejection region. In fact, it is true that 2.5% of the samples will be out there. You know, if we're using that size alpha or whatever it is that we're using here. So the fact of the matter is that there truly, even if the null is true, there are some samples out in the rejection region. That is a fact, even if the null is true. So what happens? What if you did a test and this was your sample? Did anybody remember if they got one out there? Did anybody have it? Okay, good. So Taylor had one of these ones. If her sample was the one we did our test on, she would have rejected the null hypothesis and she would have called up the M&M's company to complain to them that they are lying about their proportion of blue M&Ms. Okay, so even though it's true, that is called an error in your conclusion, and that's what we're going to talk about today. Okay, so here we go. On our page 47 notes, when you run a statistical test, you are supposed to get a sample that leads you to the correct conclusion. You are supposed to get a sample where, you know, you're getting all of these ones here in the center. You're getting all of these ones in the center just because sampling variability. That would lead you to fail to reject. Okay? But suppose sometimes you can get a statistically unlikely sample, a rare sample, like the one Taylor had gotten. You could get one of those ones that are rare. And that would make you draw a conclusion about the null hypothesis that should not have been drawn. Therefore, those incorrect conclusions that occur because you just happened to get a rare sample are called type 1 and type 2 errors. And that's what we're going to learn about today. We're going to define them today and then be able to state them in context of real-world problems. So here we go. All right, type 1 error. Here's what's happening. The null hypothesis is true. So this is like our M&M's one. So let's draw this as we discuss it. So here's what it would look like. If our null hypothesis is true, then where will all our data be located in reference to the null hypothesis? Around it. Very good. If the null hypothesis is true, then our data is here. Okay, so all our data is going to be located in that curve. And so let's go ahead and put our alpha on. So this is our rejection region out here. Okay, so we know we've got that rejection region. So if the null hypothesis is true, then most of our samples are going to be in here because of sampling variability, and we should fail to reject. But let's say, oops, you randomly got this unlikely sample, but I mean there's one out there. It's very unusual that you got it, but you got it. So you got this sample that was statistically unlikely. And because that sample is there, this is a rare sample, statistically unlikely, we had evidence to do what? Good. So that rare sample caused us to reject the null hypothesis, and we should not have. Okay, that is called a type 1 error. If the null is really true and we get a sample that causes us to reject the null, that's a type 1 error. All right, so I have a couple of ways for us to remember these things. One is, of course, a song. Another is that I've new this year, I've kind of found some cute memes that I think will be fun to look at. So let's do the song first. So if the null is really true, but we get a sample that causes us to reject the null, that's a type 1 error. Here we go. So let's take a look at that meme right here. Let's see. Okay, hey girl, I think I made a type 1 error. I shouldn't have rejected you. Okay, so would you pass that on over there? So I shouldn't have rejected you. Okay, so that's another way that you can remember this. And this is new this year that I brought this meme out, and then I practiced it on one of the problems, and it ended up kind of like confusing me because if the product worked, we were supposed to reject the null hypothesis, and so anyway, it kind of confused me when I thought of that. So I think I still like the tried and true type 2 error. Or type 1 error, it caused, let's see, what is it? If the null is really true and I get a sample that causes us to reject the null, that's a type 1 error. All right, so now let's look at another way. Okay, so here's our other type 1 error. This exaggerates it a little bit, but let's take a look at what happens. You think? I really do like this guy's face over here. He's like, okay. Okay, so here. So here's a for example. Here's what's happening. So in this case, so would the null hypothesis be that you are pregnant or that you are not pregnant? Yeah, pretty much everybody, you're not pregnant, 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 unless I get a blood test that proves to me, quote unquote, that I am pregnant if I reject the null. So the null is that you are not pregnant. So this guy's blood tests, I don't know, I guess if they're measuring the HCG or whatever it is, he'll get an average blood level in his test. Should all be in this vicinity. Okay, but here's the rejection region. And we got a rare sample that was up here. Okay, and so that made us reject the null hypothesis and conclude that he is pregnant. Okay, so there's our type 1 error. Honestly, I do think that in real life, I want to research this. This is another thing I want to kind of figure out. I think in real life what they'll do is say you get something, some industries, they'll have you run a test and make a conclusion. Well, and then they'll have you do another test and run another conclusion. If those conclusions are the same, then you're good to go, you're done, move on. If those conclusions are not the same, like if one of them sample you rejected, one sample you failed to reject, then what do they have you do? Run a third test, get a third sample, and see what that is. Okay, so anyway. All right, let's move on and do the definition of type 2 error. So here we go, type 2 error. With a type 2 error, the null hypothesis is false. So that starts out looking like this. The null hypothesis is false. If the null hypothesis is false, is the data located around the null hypothesis? No, it is not. The data is not centered here. It is centered somewhere else. So no data really close to the null hypothesis. All right. But then we have our alternative. So let's say the proportion of blue M&Ms was a little bit higher. So here is where the data was really located. The alternative is true. The proportion of blue M&Ms is really a bit higher. Okay, so here, data is here. Okay, so if the null hypothesis is false, the data should be a little bit higher there. All right. So here, though, is my alpha. And so let's draw in the rejection region. It's everything. I mean, in fact, look at all of these samples that will make me, all of these samples will lead me to make what decision? Good. All of these samples, these make me reject HO. So these samples make me reject HO. But, uh-oh, what happened? I got a rare sample right here. So this rare sample, so that rare sample caused me to make what decision? It's close to the null, so what did I do? I failed to reject. So I failed to reject a false null hypothesis. Failed to reject a false null hypothesis. Type 2 error, and that's my song. It's going to go to Barbara Ann. Do you know that one? Barbara Ann, I think it might have been the Beach Boys or something. It was an old song. People really didn't about 4 or 5 years ago, nobody really knew it. But then the Minions stuff movies came out, and they have one that's banana ba or ba 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 banana ba 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 ba. So now people know the song again. So that's good for me. Um, but it's if you fail to reject a false, null hypothesis, type 2 error, type 2 error. So if you fail to reject a false, null hypothesis. So what's happening is, see this? This is no evidence. You did not find evidence to reject the false null hypothesis. So that's another set of words in the song. You got no evidence. You did not get evidence, and you failed to reject a false null hypothesis. All right, let's do our type 2 error song. Here we go. Oh, here we go. It's too high. I need to re-sing it on a better key. Here we go. Type 2 error. Oh, type 2 error. Type 2 error. Cause we can fail to reject a false hypothesis. Type 2 error. Type 2 error. Evidence. Oh, no evidence. No evidence. Cause we can fail to reject the false hypothesis. Type 2 error, type 2 error. Oh, here we go. Why you never reject the null? Why you never reject the null? Okay? And then we'll do Hotel California tomorrow, so you'll like that one. But let's take a look at this. See, my sample did not give me evidence to reject the null hypothesis. So here is our meme. You ready? Here's our meme. Let's see here. What is this from? I don't know. Why you know reject the null? Or what's that like, that tone of voice? I don't know. Why you know? It's just... So it's like really old? Oh, okay. Oh, sorry. See, I'm old. Okay, so there you go. I see something online and I think, oh, I've heard that before. Maybe that's funny. Okay. So why you know reject the null? All right. Hey, let's do the pregnancy funny story with the why you know reject the null. Okay, type 2 error. Here's what's going on. Okay, so this is, you see this lady here? She's obviously very pregnant. Okay, so our null hypothesis is not pregnant. Okay, which we know is false. Okay, I mean, just by looking at this lady, that's what we think is, But here comes the blood tests. All of the blood tests, all of our blood tests are in this area, which would give us the state or the reject the null and say you're pregnant. But we got this sample over here. She had low HCG or whatever. Okay, so we got this sample that made us fail to reject this false null hypothesis. So we say, oh, guess what? You're not pregnant. But yeah, we got a basketball. So I don't know. She swallowed a basketball or a cantaloupe or something. Okay. Okay. So real quick, in summary, our type 1 error. Let's see. If the null is really true, but we get a sample that causes us to reject the null, that's a type 1 error. And our type 2 error caused me to fail to reject a false null hypothesis, type 2 error. Now, let's do this in context. Here we go. So turn over to page 48. Okay. A shipment of parts has arrived, and you have to decide to take the shipment or not. So you are the gatekeeper at your company. You're going to take the shipment or not. Kind of like Rita and the Lay's potato chips, They would do the 150-pound sample of potatoes and decide to take the whole truck shipment or not based on that sample of 150 pounds. All right, the manufacturing company that the parts are shipped from says that the specifications for the parts in the shipment show an average length of 2 inches. So mu is the average length of the parts in the shipment, and the company claims that they are 2 inches long. I didn't define, we can go ahead and define, because on the homework you will be doing that, you'll define the parameter. So mu is the average length of parts in the shipment. This assignment today will have averages and proportions because they are just word problems. You're not computing stuff. When we've been computing, we've just been computing proportions. So today you could come across averages. So don't forget those. Use mu. All right. Then the alternative hypothesis is saying that the average is not 2 inches. Okay. So let's define in context a type 1 error. So I'm real bad at keeping things in my head, so I have to write this down. I go, okay, the null is true, but I reject it. Okay, so I kind of have to make myself a little note there because I'm not good at keeping all that stuff in my head. So let's see, what would that mean in context of this problem? The null is true. That the average length of the parts in the shipment is what? Indeed, 2 inches long. Good. So the null hypothesis is true. So indeed, the average length of the parts is 2 inches. In other words, it's a good shipment. So that's the truth. Okay? But, and I want to make a new song. I don't know if I really will do it because it's kind of, I got big butts with, I got this error stuff going on. I got big butt with here because we got an unusual sample. Hadn't decided how I'm going to do that one, but that's kind of floating around in my head. May not do that this year. Okay? But, what happened? We got a rare sample. So with these errors, we got a big butt that is a rare sample that makes us think or conclude that mu is not equal to 2. In other words, it's a what? We think it's a bad shipment. Okay. So reality is it's good, but we get a sample that makes us think, that gives us the impression that it is bad. So what's the consequence of this error? What's going to happen as a result of that? You do not accept a good shipment. You actually are sending back to the manufacturers. It says up there, if it's not good, you send it back. So you send back to the manufacturer a good shipment. What do you think the manufacturer thinks about that? They are mad. They are not happy about that. Okay. All right. Next. Okay, type 2 error. So I got to think of that in my brain. Okay, that's my song. I go, I failed to reject. Failed to reject a false null hypothesis. Type 2 error, type 2 error. Okay, so that's what I thought in my brain. Okay. So let's see here. Okay. So what's the truth? I mean, what's going on? Okay, good. I'm going to use just letters here. This average of the parts is not equal to 2 inches. And here comes the big but. We got a rare sample. To make us think what did that rare sample make us think? Yeah, that the average length is 2 inches. Okay. So it's a bad shipment, but we got a rare sample to make us think it's okay. What happens? Yeah, we accept, my company that I am the gatekeeper for accepts a bad shipment. All right? So, again, I want you to imagine this is a real life scenario. I bet that this is a case where they want you to run two tests. They'll take a sample, run a test, and get a decision. Take another sample, run a test. If it's the same decision, carry on. And that way you kind of minimize your risk of the errors. But anyway, what type of error would you, the shipment inspector for your company, really want to avoid? Why? Yeah, so you don't lose your job. How about that? Um, so you don't give your company bad parts. Um, what if this is like brake parts? You accepted brake parts. Your company puts them on the vehicles that they're making. They now, then all these lawsuits start happening because people are dying because the brakes aren't working. And that's all because you accepted a bad shipment. Okay? All right. There's a little extreme, but you got it. Okay, let's do another one real quickly. Here we go. Example 2. Only about 20% of people who try to quit smoking actually succeed. So is this a mean or proportion problem? Okay, so P is the proportion of people who actually quit smoking that watch the motivational tape. Okay, the proportion P equals the proportion of people who successfully quit smoking, and we're going to introduce a motivational tape here and have them do that. So sellers of a motivational tape claim that listening to the recorded message can help people quit. So we're going to then test that. We're going to take people who listen to the tape and see if the proportion is still 0.20. That would be our null hypothesis. If the proportion is still 0.20, what is that saying about the tapes? If the proportion that quit is still 0.20, what can you tell me about how the tapes are working? Yeah, tapes don't work. I kind of like making myself a little note over here. All right, the alternative says that it is now, what do you think? In order for the tapes to work, what would the proportion of people that quit smoking that listen to the tape be? Greater than, okay? All right, so this one, the tapes do work. Yay. All right, so I want you to take a few moments and do turn this problem down here, type 1 error, and then go up to the top of the next page and do those. So I'll give you a few minutes for that. Okay, let's see how you did. I kind of filled in some things. Type 1 error. Null is true. So the proportion of smokers that use the motivational tapes that quit is what? The null is true, so it's actually what? Still 20%. But I get a sample that causes me to reject the null. So what do I think? P is greater than 0.20. Okay. So the tapes don't work, but I think they do. So what's this consequence? Well, I guess I just said it. Tapes don't work, but we think they do. I mean, and you could also say here, I mean, I'm kind of unclear on how far I want you to take this consequence. What ends up happening? People do what? People waste their money and they buy something that doesn't work. Okay. So people waste their money. People buy a product that doesn't work. All right, let's do the next one. Can I put like a bad word here? Or I'll just say stinks. In other words, doesn't work, but stinks is shorter. Okay, type 2 error. I failed to reject a false null hypothesis. So the null hypothesis is P equals 0.20, and that's false. So I should have rejected it. So truthfully, the proportion of smokers that use motivational tapes who quit is greater than 20%. So the tapes are working, but my sample makes me think that the proportion is still 0.20. So what does that mean? What's the consequence? What's actually happening? What will the manufacturer do? Yeah, stop making the product because they think it doesn't work. Okay, so they stop making product because we think it doesn't work. You could also put things like, you know, people are losing out on something that could help them. Stop making product because we think it doesn't help. So people are missing out on a product that could potentially help them. That's another thing. All right, so if you are the marketing director for a company, you're the marketing director for the company that makes these motivational tapes, keeping in mind that it's a business and the goal of the business is to make money, not help people's health, okay? You know, we would like to think it is, yay, let's help people's health, but it is make money. So if you were the marketing director for that company, what type of error would you prefer to be made? Type 1, because you're selling the product. Okay, good. So your assignment is to do pages 50 and 51. Here's some information here. Anyway, so I'll let you work through that and putting things in context and all that kind of stuff. All right, that's it. You actually could probably come close to finishing this in class if you worked for the next 15 to 20 minutes.